In this video, we're going to analyze proofs to write paragraph and flowchart proofs. So these are new types of proofs. We've been used to doing a type of proof that looked like this, where we have two columns, our statements on the left and our reasons on the right. This is one we did in class where we're proving that angle 1 is congruent to angle 2. In this proof, we actually proved the alternate exterior angle theorem. So we had that A was parallel to B. Those lines are parallel, which means that angles 1 and 3 are congruent because of the corresponding angles postulate. If those lines are parallel, that means corresponding angles are congruent. We know 2 and 3 are congruent because of the vertical angle theorem, that those are vertical angles. And because 1 was congruent to 3 and 2 was congruent to 3, the transitive property allows us to cut out that middleman and take angle 3 out and say angle 1 is congruent to angle 2. That's our two-column proof. Now what we're going to do is put that in what's called a paragraph proof. A paragraph proof is a more informal way of proving mathematical theorems or properties. The paragraph proof just writes out in full and complete sentences what we've put in our flowchart proof. So in this example, we have given that the lines are parallel, we can show that the corresponding angles 1 and 3 are congruent because of the corresponding angle postulate, which is exactly what we put in step 2. We can also use the vertical angles theorem to show that angles 2 and 3 are congruent, which is what we had in step 3. Due to the transitive property, we can conclude that angle 1 is congruent to angle 2, which is what we have in step 4 to reach our final conclusion. The flowchart proof for this works just like a river does. It's going to flow down to that conclusion. So we start out with our given information as the top of our proof. This flowchart proof is also an informal way of proving a mathematical idea. The formal way to prove is the two-column way that we've been used to doing. This flowchart proof is really important because it tells us how the things are connected together, how these properties flow into the next idea and flow into that conclusion. So we are starting out with our given information, like we always do. We're given that A is parallel to B, and that directly implied that angle 1 was congruent to angle 3. The corresponding angles being congruent was because those lines were parallel. So we have the pieces in our flowchart connected. Now, those vertical angles being congruent did not flow directly from our corresponding angle postulate or from the fact that we had parallel lines. We don't need parallel lines to prove vertical angles are congruent. We just know from our picture that those are vertical angles. That's what vertical angles are. So notice how this part in our flowchart is not connected to either one of those pieces. It starts a new branch or a new piece of our river to flow down to our conclusion. So it's a new branch in our flowchart that then comes back together using the transitive property. So notice how this green transitive property conclusion is connected to both the vertical angle theorem and the corresponding angle postulate statement. Because we said 1 was congruent to 3 and 2 was congruent to 3, both of those statements were used to conclude that angle 1 was congruent to angle 2 by the transitive property. So you can see directly how those properties and statements are connected using that flowchart. In our two-column proof, we have all of our steps, but it's not readily apparent as to why the corresponding angle postulate was used. In the flowchart, we can definitely see that it's connected directly to the lines being parallel. So we have another proof to take a look at. We are given that line J is parallel to line K, and we want to prove that angle 1 and angle 7 are supplementary. Now, just taking a look at this picture here, 1 and 7 are not a type of angle pair that we're used to proving with. We're not going to be able to use the corresponding angle postulate or the alternate interior angles theorem or any of those other shortcut theorems that we've been using to shorten our proofs with. We're going to have to relate one of these angles to another angle and then work our way to proving that angle 1 and angle 7 are supplementary. So we can notice here that we do have those types of angle pairs with angle 1 or angle 7. So angle 1 is consecutive interior with angle 4. And so we know from our consecutive interior angle theorem that 1 and 4 would be definitely supplementary. Because we know they're supplementary, we know angle 1 plus angle 4 must equal to 180. And that's the definition of what supplementary means. That directly follows from that statement above it. We also know from our picture that angle 4 and angle 7 are congruent because they're vertical angles. And them being congruent means that their measures are going to be equal by the definition of congruent. Because we know 4 and 7 have equal measures, we could substitute angle 7 into angle 4 into that equation that we stated previously. So the measure of angle 1 plus the measure of angle 7 is equal to 180 by substitution. Now that we've proven that angle 1 and 7 add to equal to 180, we can now state that those angles are supplementary, which is what we were trying to prove. Because they added to 180, we knew they were supplementary because of the definition of supplementary. So that's our two-column proof. We would then want to write our paragraph proof, which would just state in full and complete sentences what we've already done in our two-column proof. We are given that lines J and K are parallel. Because of the consecutive interior angle theorem, we can show that angle 1 and 4 are supplementary. The definition of supplementary means that the measure of angle 1 plus the measure of angle 4 equals 180. Angle 4 and angle 7 are congruent because of the vertical angles theorem. Since angles 4 and 7 are congruent, we know their measures are equal because of the definition of congruence. We can substitute the measure of angle 7 in for the measure of angle 4. Because the measures of angle 1 and 7 sum to 180, we can conclude that angles 1 and 7 are supplementary. So that paragraph directly reflects what we put in our two-column proof. Now let's work on a flowchart for this. So again, we start out with our given, and we want to only connect things that directly are related to that given information. Well, J being parallel to K gave us that 1 and 4 were supplementary, because the consecutive interior angle theorem says if the lines are parallel, consecutive interior angles are supplementary. So this statement followed directly from J parallel to K. Those angles being supplementary meant that they added to 180. So the definition of supplementary followed directly from that 1 and 4 being supplementary. Notice then how we branched off and we have a new branch over here. The vertical angle theorem did not branch from the parallel lines or from the angles adding to 180 or being supplementary. Notice how this piece in our flowchart is not connected to any of those pieces. It did not flow directly from any of those pieces. None of those statements directly imply vertical angles. We just know vertical angles are congruent from our picture. So we have a new branch here that states our vertical angles are congruent. Then because we know the angles are congruent, that directly implies the measures of those angles are equal. So notice how the measures of 4 and 7 being equal directly follows from the fact that they were congruent. The next thing that we did was we substituted angle 7 into the equation for angle 4. So we used both of these steps to then conclude the measure of angle 1 plus the measure of angle 7 equaled 180. So notice how the flowchart joins back together for that substitution step. Then once we knew they were adding together to be equal to 180, we knew that angle 1 and angle 7 were supplementary. So we reached that final conclusion down here at the bottom.